So linear equations is something that you have learned in the 7th standard, linear equations. After linear equations, we learned about simultaneous equations. And after simultaneous, we learned about quadratic equations. Okay, these are all coming under the topic called algebra. So what is linear inequations now? Last year, you had a chapter called inequalities. That was to do with triangles. This is not that. Linear inequations is just like linear equations, but instead of having an equal to sign in between, you will have a less than or a greater than sign. That is linear inequations. Okay, so now let me give you an example. In linear equations, if I give you 3x is equal to 7 minus 5x. Okay, how do we solve this? How do we solve this linear equation? A simple linear equation. Okay, you'll take all x terms to one side, numbers to one side. So if you move the minus 5x to the left, it will become plus 5x. So plus 5x, and then you have your plus 3x is equal to 7. Then that will be 8x is equal to 7. Then x is equal to 7 upon 8. This is how you will solve this linear equation. Now we're going to solve this linear equation. I'm using the same values. So on the left side, we'll put 3x. On the right side, we'll put 7 minus 5x. So you will solve it in the exact same way. No difference. So you'll take the minus 5x to the left. That will become plus 5x plus 3x less than 7. So 8x is less than 7. Then x is less than 7 upon 8. You see? Same. No difference. This is a linear inequation. So what's the difference between a linear equation and an inequation? In a linear equation, x has only one value. The value of x is 7 upon 8. That's it, just one value. But in linear equation, it's a range of values. So here I'm saying x is less than 7 upon 8. That means the values of x is everything less than 7 upon 8. Is that clear? Everyone clear about what's a linear inequation? Linear equations has a single value as x. Linear inequation will have a range of values. Okay? All right. So in linear equations, we can only use equal to sign. In inequations, you can use less than, equal to, then greater than, equal to. Okay, these these are called relational operators, I think, in maths. You can use any of these 4 relational operators. I'm using computer words, but yeah, you can use any of these. Here we call them inequations. You can use any of these 4 inequations or signs of inequalities. Let's read this statement in this box here. In an inequation, the signs greater than, less than, greater than, equal to, less than, equal to are called signs of inequality. Okay? So sometimes you use the word inequation, sometimes you use the word inequalities. If you remember last year, I got mixed up and I thought you're learning this one. Then we started off and realized it was about triangles, right? Because they, instead of inequations, they use the word inequalities. So I thought it was the same because they are actually the same. Okay, either they call inequations or inequalities. All right, so very similar to this chapter in equations, just there are some small differences when minus sign comes. Okay, when x becomes negative, there will be some small differences. We will see that when it comes. Okay, so let's try to solve one inequation. Let's go to the exercise. Exercise 4A, question 4 in my book. If the replacement set in the set of whole numbers, if the replacement set is the set of whole numbers, solve this. Okay, so we'll see what that question actually means. Let's look at the equation, the inequation. So x plus 7 less than equal to 11. All right, so simple. So take the 7 on the right side. So x is less than equal to 11 minus 7. X is less than equal to 4. Okay. Yes. So x is less than equal to 4 means everything 4 and below. So 4, 3, 2, 1 and so on. Okay. But before you do that, you have to see what this means now. So they're saying if the replacement set means your x values can be written as a set. Remember sets we had learned in these curly brackets. So you'll write all the values in a set. That is called a replacement set or just a set. Now they're saying that this replacement set is a set of whole numbers. So we had natural numbers, we had whole numbers, we had integers, which is I or Z, and you had rational numbers. Do you know the meaning of each of these words, all of you? Natural numbers means what? What are natural numbers? Starting from 1. So 1, 2, 3, 4, and so on till infinity. These numbers are called natural numbers. What is W is? Whole numbers. What's a whole number? Yeah, you start from 0. 0, 1, 2, 3, and on till infinity. Then what's an integer or Z, which is integers? These are all minus and plus, all the negative and positive. So you start from minus infinity and go until plus infinity. So every number. Now all these three are numbers without decimal points. Rational numbers are what? They are every number, that is every decimal number, every fraction, they come under rational numbers. Okay, so these are the 4 types of numbers that can come in this chapter. So they will mention that for every question. Okay, so now in this question, what is it? Whole numbers. You see that? The replacement set is a set of whole numbers. So tell me what will be the numbers inside this bracket? X is less than equal to 4. Yeah, so 0, 1, 2, 3, 4. Starts from 0 because it's whole numbers. And x is less than equal to 4 means you include 4 also, till 4. Is everyone clear with this? Okay, now in linear equations, we would have stopped with this. This would be a final answer. But in linear inequations, they will either ask you, they will ask you sometimes the replacement set like this, and sometimes they will even ask you the number line. You'll have to draw these values on a number line. So how do we draw this on a number line? Now in this question, they have not asked to draw the number line, but sometimes they will ask. If they ask a number line, then you have to put all these values on the number line. So it's 4 and below, right? So here you put 4, here you just put 5 also. Just add one extra number. And then 3, 2, 1, 0, minus 1, minus 2. You're just writing some numbers. And from this, you're going to mark all the numbers that are in this solution set or replacement set. So that is 0, 1, 2, 3, 4. We'll just put a circle on top. Okay. This dot on top means 0 is included, 1 is included, 2, 3, and 4.
Sir, I didn't understand this number right now.
What didn't understand?
This number line one.
Number line means you just put the numbers. What all numbers are there should be included in the number line. So 0 to 4, that 0, 1, 2, 3, 4 should be marked here. If you want, you can put 5, 6, 7, 8 also front of this. And below this, you can go more, minus 3, minus 4. It doesn't matter. You're only marking 0, 1, 2, 3, and 4. It's not compulsory that you have to go only till 5. But don't stop at 4. Just go at least one number more than 4. And on this side also go one number less.
Question number 3, can you solve?
We will solve, okay, based on what I'm giving you. Is this clear for everyone? Okay, so this answer, this is the values of x. When you pay, it is called the replacement set. Ahmed, I'm keeping you on mute. Your internet is bad. I cannot understand you. Just listen, okay? So this is called what? This is called replacement set. And this is called the number line. Okay. All right. Just write down this question and write down the answer for this. 4, 1. They have not asked to draw the number line, but you draw the number line now just to get a practice of it. After doing this first one, do the fourth one. 4, 4. Okay. You want to write this also? Write this also. Heading, this is equation, and this is inequation. Okay, the fourth one, did you all get something? Okay, now here there's a new rule that is there for inequations. Just look at this. Did anyone get this much? See what I've done here. So 7 minus 3x is greater than equal to minus 1 by 2. So I kept the minus 3x over here. I took the 7 on that side. So that became minus 7. And then the shortcut is 2 into 7. That's 14. So minus 1 minus 14 upon 2, which is minus 15 upon 2. Okay. Now look, what would you generally do if it was a linear equation now? What would be the next step? You will take this minus 3 on the right side. So you will get x is greater than equal to minus 15 upon 2 upon 2 into that minus 3 will go down, no? This is what you would generally do for linear equations. But in inequations, when you're removing the minus sign, no, there's a change that will happen. Okay. So don't remove the minus sign right now. Keep the minus there with the x. And you're only taking the 3. So here this will be what? Just 2 into 3. Okay. So that is minus x greater than equal to, you can cut this 15 and 3, so it will become 5. That's minus 5 upon 2. Correct? Now look very carefully. When we take the minus on the other side, this greater than will become less than equal to. Okay, the sign of the inequality will change. If it's greater than, it will become less than. This is when we change the minus. If you remove the minus to the other side, the sign of the inequality will change. Plus means you leave it as it is. No, we don't do anything. Anything, even if plus becomes minus or minus becomes plus. If you change the plus or minus sign, the inequality also will change. So that will be x is less than equal to. Now this minus goes there and makes it plus. That will be 5 upon 2. You saw this? Okay. So I'll give you some examples of that here. Tell me the answer. What if you have minus x less than 5? What will this become?
X less than minus 5.
X is greater than minus 5. Another example. Suppose I have minus x less than minus 5. What will this become? X greater than 5. The minus will go to the other side, make it plus, right? Yeah. Okay. Is this clear, everyone? Any doubt in this? This is if there's a negative sign for the x and remove the minus, this is what will happen. Okay. Now what happens to 5 by 2? 5 by 2 is an improper fraction. The numerator is bigger. So convert it to a mixed fraction. So what will that become? Tell me without doing this.
2, 1 upon 3.
2, 1 upon 2. So remember how to do this, everyone? You have to think in your mind. 2 into what is 5? So 2, 2's are 4. Put the 2 there. Remainder is 1. So 2, 1 upon 2. X is less than equal to 2, 1 upon 2. Okay. Now you have to write this as a replacement set. So what will the values of x be? Remember, x is a set of whole numbers. So tell me all the whole numbers which is less than or equal to 2, 1 upon 2. See on the number line, this is 1, this is 2, this is 3. Where is 2, 1 upon 2? Should be here, no? Between 2 and 3. That's 2, 1 upon 2. So what are the whole numbers less than 2, 1 upon 2? 0, 1, 2. Correct? Less than this is 2. 2 is the first whole number that's below that. So 0, 1, 2 is your solution set or your replacement set. Even though it says less than equal to 2, 1 upon 2, we can't write 2, 1 upon 2 here. That's not a whole number. Right? The first smallest whole number below this is 2. Is it clear, Aman? Right. Next, do the fifth one here. What did you all get for this? X is less than 3 upon 2. So less than, show what you did. You should get this as your answer.
Yes, sir.
Yeah, see, there's one thing. So one more thing I want you to notice, this is the last difference between equations and inequations. Suppose I have like this, 3 is greater than x, okay? And we want to interchange these two. We want to put x on this side and 3 on that side. Listen very carefully. When you do this, your greater than will change to less than. If you interchange both the sides, your sign of the inequality will change. That's what happened there. So you have to change that.
Can you do minus x and minus 3?
What?
Minus x and minus 3 it will become?
If signs are changing, that way also the inequalities will change. And if you change left side and right side also, then also the sign of the inequality will change. These are two cases where the inequality will change signs. First one was we saw, when was the first change? If you change the minus sign. In other words, if you're multiplying minus on both the sides, then the sign of the inequality will change. This is clear, everyone? The second time when the inequality will change signs is if you're interchanging left side and right side. Okay. All right. Now, some of you would have done it. Let's do the other way. That is, let's take the x terms to the right side. Okay. So if we take this x term to the right side, what will we get is minus 3 upon 2. Then take this 3 upon 2 to the left. That's minus 3 upon 2 less than minus x, and that x will go on the right. So minus x minus x. Correct? So here minus 3 upon 2 minus 3 upon 2 will become minus 6 upon 2 less than minus 2x. Here we can cut 2 and 6. That's 3. So minus 3 less than minus 2x. Now what we're supposed to do? Take the 2 on that side or minus 2 on that side? Don't take the minus 2. Take only the 2. So it will be minus 3 upon 2 less than minus x. We're leaving that minus there itself. In the last step, we will take the minus on that side. So now if we take the minus on that side, this minus 3 will become plus 3 upon 2. And this less than will become greater than x. You understand? And then we'll interchange both the sides. We'll take x on the left, 3 by 2 on the right. And when we do that interchanging, again this will change. So it will be x is less than 3 by 2. And then you're left with the same thing that you got it. Okay. So instead of doing so many of these changes, just try to see that x is positive. See here, all these problems came because x became negative. So what did I do is I kept x positive. Move the minus on the other side so that x remains positive. But is this clear? Because you'll get questions like this where you'll have to remove the minus from the x. When you remove the minus from the x to the other side, the less than will become greater than. And then if you interchange both the sides, again the inequality will change. Okay. Now x is less than 1 by 2. So what is your solution set here? 0, 0 and 1. Correct? Okay. All right. And your number line, did you draw the number line? You can start with minus 1, 0, 1, 2. And you just mark 0 and 1. Yeah, so real numbers are all the rational and irrational numbers. Now, we don't study too much about irrational numbers. So basically, when we say real numbers, we mean rational numbers. That means all the decimal numbers, all the fractions, everything. This is real numbers. Okay. Now, if I ask you to write all the real numbers between 5 and 10, okay, for example, if I write 5 less than, or let me just say it like this. Okay, 5 less than x less than equal to 10. Okay. What does it mean? 5 less than x less than equal to 10? It means all the numbers between 5 and 10. But 5 is not included. 10 is included. You understand the meaning of this, everyone? 5 less than x less than 10 means this x is in between what? Between 5 and 10. Where in which 5 is included or not included? Less than sign means, are you including 5? No, you're not including 5. Less than equal to 10 means you're including 10.
Can you tell again?
Yeah, join first time. Don't waste time. Don't wait to join. Okay, then you'll miss out. Okay, so I'm explaining two things right now. First, I'm explaining what is a real number, and I'm also explaining what is the meaning of x written in between the 5 and the 10. Okay, so let's see this first. First time I'll tell you in terms of integers, and then we'll see what is this if it's a real number. Now, if it's 5 less than x less than equal to 10, and if they're integers, what is the solution set? 6, 7, 8, 9, 10. Correct? See, you're not including 5. There's no 5. But 10 is included. Okay. And this can be represented on a number line. On the number line, you will mark all these numbers. You'll start with 5, but don't mark 5. You'll mark 6, 7, 8, 9, 10, and you'll write one more number after that, which is 11. This is how you'll represent this on a number line. Correct? Is this clear, everyone? This is if they're integers or natural numbers or whole numbers. This is how you would do it. Now, what if they are real numbers? 5 less than x less than equal to 10, where they are all R. R means what? Real or rational. Okay. Real numbers are all the rational and irrational numbers together. So irrational is irrelevant for us because we don't study about irrational numbers. But real numbers are all the rational numbers. Now, can we write all the rational numbers between 5 and 10 in a solution set or in a replacement set? That means all the decimal numbers and all the fractions between 5 and 10. Can we do that? No, it would be infinity. There would be infinite numbers. For example, after 5 is not included. So the number after 5 would be 5.1 or 5.01 or 5.001. There is no end to the number of numbers between 5 and 10. So example, you'll have 5.1, 5.11, 5.11111. Like, you have so many numbers. So the problem is what? Real numbers cannot be represented as a replacement set. Is that clear, everyone? Real numbers, you cannot write it in brackets. Only integers, natural numbers, and whole numbers can be written as a replacement set. For real numbers, you cannot put it inside a replacement set. But we can draw number line. Okay, so let's see how to draw the number line. It's slightly different. So we'll start from 5, 6, 7, 8, 9, 10, 11. Okay, now this is how you're going to draw it. 5 is included or not included? Not included. So you'll put a circle around it. 10 is included or not?
Yeah.
Yes. So for 10, you'll put a black circle. You'll color it like this. Okay. And between 5 and 10, you will make it dark. With your pen, you just draw 1 or 2 lines on it. This is how you draw real numbers. So what this means is you're including everything in between, right? All the decimal numbers between every integer here you're representing. That's why we're drawing this dark line to show that we're representing everything. For 5, white circle. For 10, dark circle. White circle if you're not including it. Dark circle is if you are including that number. Is everything clear how to draw real numbers on a number line? Okay. All right. So write down these two, and after that you will start with your 7, 1. Write down this much.
That arrows, small arrows, how you mark the number line 5.111?
Small arrows you don't need to mark. What I'm just showing you is that you're including everything in between. That's why I just showed that. You just make it dark between 5 and 10. So what did you all get here for x? X is less than equal to 12 or 12?
Less than is equals to 4.
4, no? You're doing this, no? We get divided, no? You minus to what? What is this one? Minus 4x greater than equal to minus 16. So first you take the 4, leave the minus x here as it is. Greater than equal to minus 16 upon 4. That's minus x greater than equal to minus 4. Then take the minus on that side. So x is less than equal to plus 4. Did you all get this? This is what you're supposed to get. If you made a mistake, you won't get this. Now, how do you represent this on a number line? They have not asked here. Okay. But if they ask you, how do you represent this on a number line? X is less than equal to 4. So less than equal to 4 means 4 is included. So we'll start with 5, 4, 3. Until where does it go? Do we stop at 0? No, they are real numbers. Real numbers means all negative, positive, decimals, fractions, everything. So we cannot stop at 0. So it goes, keeps going. Okay, we'll write till minus 1. And here 4 is included. So what circle? White or black? Black. Okay. And then you just darken everything before this. Till the arrow. Even the arrow you make it dark. That means what? You're including everything till infinity, till minus infinity.
Yeah.
Okay. Is everyone clear with this?
And do we have to write x such that x belongs to our?
I don't think you have to write that. Did you learn that? Was that taught you?
Yeah.
Let me just see. See this question here. Solve and graph the solution set. So they have just drawn the number line. They didn't write it like that. I've not seen that anywhere here. Just see in the textbook if you can see an example where. Okay, here is written. If the replacement set is a set of real numbers, find the solution set of this. Okay. Okay, so since you cannot write the solution set with the numbers as it is. So you can write it this way. Write it like this. X such that x less than equal to 4. Then put a comma and write x belongs to R. Just write that much. So this is your solution set or replacement set because you can't write the numbers. So write it this way. Okay, all right.
In this you put the number line -1. I didn't get
What?
-1 on the number.
Yeah, you can put -1 till -2 or -3, doesn't matter because it's going till minus infinity. So I just wrote -1. You can stop at even 1 or 2 also, doesn't matter. Okay, now I'm going to show you some number lines and you will tell me what is this in equation, like x is less than 4 or whatever you say it for that number line. Okay, here. Look at this number line and tell me what it is. X is less than equal to 2, is it correct?
X is less than 2.
Less than 2, not less than equal to 2. You see, it's a white circle. That means 2 is not included. So x is less than 2. And it's going all the way till minus infinity. And x belongs to R. It's a real number or rational numbers because there's a dark line. You're including everything. If it was integer or something, then you won't draw a dark line. You will draw separate dots for each number, right? Okay, next one.
Less than equal to 2.
X is less than equal to 2 and x belongs to R, right? Okay, here. Look at this and tell me. It's not very clear, but -1 has a black dot and 5 has a white dot. So how would you represent this? So this has,
-1.
yeah, see, this has a starting and ending, no? So you have to put both the numbers with x in the middle. X in the middle, one number here, other number here. So where is it starting? The smaller number is -1. Then is -1 included? So less than
Yes.
equal to. And here is 5. Is 5 included?
No.
So less than. No, it's a white circle. It's not very clear. That's a white circle. This is a black circle. Everyone clear on this? There are some here, but the answers are given. Don't look at the answers. Just look at the numbers. It's not clear. I don't know if you can see. But here 4, from 4 onwards. So how is this?
Greater than equal to 2.
X is
X is greater than equal to 2.
x is greater than equal to 4. And x is real numbers. Next one. It's starting from -1 till 4. So you have a starting and ending. So you don't start with x. X will be in the center now. When you have starting and ending, x will be in the center. And you put one number on the left, one number on the right. So starting from where? -1. And here less than or less than equal to? Less than equal to. -1 is included. Until 4. 4 is included. So less than
Yes.
equal to. Clear? This also can be written as -2 less than x less than 5. Is this also correct? -2 onwards, but you're not including -2. So that means the next number is what? -1. And then less than 5 means you're not including 5. But what's before 5? 4. So you see both are correct. Is that clear? All right. Any doubt in this, anyone?
No, sir.
Okay, next 7, 3. We'll do 7, 3 and 7, 4. Okay, do 7, 3.
No, x greater than or equal to -4.
Okay, anyone else? X greater than or equal to -2?
-4.
-4. Ivan, what did you get?
X greater than
X greater than 8. 8, 0. Ooh. How greater than equal to? Menora, this is greater than, no? You're doing 7, 3, no? From my book.
No, different question.
You're a different question. Do from here. I'm following this, no? Huh?
I can't see it properly.
Okay, I'll just write the question here. 5 plus x upon 4 greater than x upon 5 plus 9. Aman, what did you get?
I got -4 less than -4.
Huh?
No, greater than
So make LCM, make the denominator same.
Okay.
Anna, x greater than 80.
X greater than 80. What about the others? All the silent ones at home? Ryan, Nathan, Gloria, Ahmed. Isn't it?
Yes, sir, x greater than 80.
Don't know x minus 4x plus 5x.
Oh.
Why are you not doing it? So direct now. Those of you finished, you can go to the fourth one. It's cross multiplication.
I got -1 x upon 23 greater than -2. Can I convert 4 and 20?
1 minute. -4. How -4 you got? -5 plus 9 is how much?
-5 plus 9 -2.
Your addition subtraction is wrong. You have to put the sign of the bigger number, no?
Oh, yes.
Okay, x is greater than 80. So you'll write this as x such that x greater than 80, comma, x belongs to real numbers. That is your solution set. On the number line, you can just draw 80 or start with 79. Go 80, 81, white dot, and a line.
Anna,
Yeah,
is it x less than, no, x greater than 3.
x greater than 3. What do you got? Tell me what you got.
12 x greater than 12. 2 upon
12, 2 upon 3.
less than.
Hey,
Anna, sorry,
Uh.
x greater than 30.
x greater than 30.
1, 3, 1, 3, 13.
X greater than 13. You got x is less than 12, 2 upon 3. Wait, what you wrote 5 here, no? This down number? No, you took 5, no? This denominator?
Yes, Anna.
Okay, so cross multiplication, that will be 5x plus 15 less than 8x minus 24. Yeah? Take the 8x to the left. What did you do? Did you all take 8x to the left or 5x to the right? 5x to the right? Okay, let's do that. So that's 15 plus 24 less than 8x minus 5x. That's how much? 30? 39. 39 less than 3x. So your mistake is. Then take the 3 down, so it will be 13 less than x. And then you interchange both, that is x is greater than 13. Minora is correct. Solution set, number line. Okay, so now your homework is to solve all of these questions, whatever is remaining. Some of the questions you will see, just look at this 11th question here. That's -5 less than equal to 2x minus 3 less than x plus 2. Do you see there are two less than signs? Any question that has two of these signs, you don't do that. That I will explain to you in the next class. Okay, but all the other questions which has just one sign in between, one less than or one greater than, you solve all of those questions. So from this whole exercise, which question you can't solve? You can't solve 11 and 12. 12 also has two of them.
So
So
that is not there in a book also.
Then
Only
the
till 9th question in the book that
Show me
is
a
there.
book.
middle line.
Okay, so that means from your book, you can solve everything. So from exercise 4A, 5th, 6th, 7th, 8th, 9th, 10th, 5 to 10 is your homework.
So can you explain 9th in your book?
9th,
No, it's in your book. It's in your book. Can you explain?
see there are x terms, no? Same thing. Take the x terms to one side, numbers to one side. You'll have fractions. So you have to make the denominator same and solve the fractions.
And we have to find the smallest value.
Oh, find the smallest value of x for which x is an integer. Yeah. So out of the integers, that you get, what is the smallest integer? That's the question.
In bracket we have to mark on the number, so we have to take that smallest value, no?
Right over there is a statement. The smallest value of x is equal to dash. For example, if x is
Yes.
2, 3, 4, 5, the smallest value is 2. So like that. Okay, exercise 4b, question 1, 1. 2x minus 1 less than 5. Okay, so x terms on one side, numbers on one side. So 2x less than 5 plus 1, where 2x is less than 6 and x is less than 3. Okay, so this is the value of x. Now representing this on a real number line, how will this be? What about 2.1? Are we including that? 2.9? Why? Is 2.9 also included? X is a real number. Okay, real number is every decimal, every fraction, every number. So if I say x is less than 3, what does it mean? Is 3 included? 3 is not included, but everything below 3, which means even 2.9999999 is also included. Right. So it's not just 2 onwards. Okay, so how do we represent this on a number line? Okay, here what should I put? I'll put 4. Here I'll put 3. Okay. Then 2, 1, 0, minus 1, minus 2. So now 3 is not included. So what do I do for 3? White dot or black dot? White. Just a circle. It means 3 is not included. If I make it black, what does it mean? 3 is included. That is, if it was less than equal to, I'll have to put a black dot. But if it is less than, then I have to put white dot. Now x is less than 3. That means from 3, everything to the left. So just make this line dark all the way till the left. Till minus infinity. So it goes. All right. Okay, so now you all do these questions from 1. Okay, now before you continue on, the answer like this x, you could have just one number on one side, or you could have numbers on both the sides of x. Okay, like here you have x less than 3. Sometimes you'll have something like this, -1 less than x less than 3. See, now you have numbers on both sides of x. What does this mean? It means the x values are between -1 and 3. Got it? Here how it is, x is less than 3 means what? It's less than 3. So it's going below 3 till where? Till infinity. What if it is x is greater than 3? Then what does it mean? It's above 3 till where? Infinity. But if you have two numbers on both the sides of x, it means x is in between this. It has a starting point and an ending point. Okay. So here in this, some of these questions are like that. Like if you see from the 4th question onwards, see x is in between -4 and 4. Here x is in between -2 and 5. Here x is between 8 and -3. See the reverse here, big to small. That's why they have the sign is different. Instead of less than, they put greater than, greater than. So 8 is the greatest till 3. What happened? Played and came. Then no 15. 4:45. Who said 15? 45. Latest 50. Okay. So here, in the first, second, and third question, you just have one inequality in between, less than. So it will be from one number till infinity or this number till this minus infinity. But if there is two less than symbols, it means x is in between two of the numbers. Okay. Most of the times you will see the less than sign like this. -1, less than x, less than 3. So when you see less than sign, it means you're going from small to big. What if it's the other way, like this? Then you will write the big number first. So if I'm reversing this, what will it become? 3 is greater than x greater than -1. Okay. So both are correct, but we don't prefer writing it this way because it's confusing backwards, big to small. So we always write it like this. That is from small to big. In other words, always try to use less than sign, not the greater than sign. Okay. So you all do these questions from here. 1, 3, 5, and 7. You just have to draw the number line. 1 and 3, you have to solve it. You have to find x. 5 and 7 are already solved. You just have to put them in the number line. Okay. Do these. Solve question. This is exercise 4B from my book. Question from 1 you have to do 1, 3, 5, and 7. Represent the following inequalities on a real number line. For the first and third, you have to solve it and find x. And then I've done the first one for you. For the fifth and seventh, they're already solved. You have the values of x between these two numbers. So you can directly put it on the number line. There's nothing to solve. Okay, start. Do and send a photo to me.
Yeah, I was having doubt.
What?
I got a x greater x less than equal to 5.
Which one?
Then how? Question 6 in
6.
our book.
Which question are you in? 4A, 4B? What is this now?
4a.
4A.
Yes, in your book it will be 5.
That is, you mean homework?
Yes.
What about the homework?
Question 5.
See, you all should join early and then because in the beginning of the class we check homeworks and everything. Now in between, no, while doing the next exercise, in between, if you ask like this, no, it's confusing. All of you, please join on time. 4:45 means be here by 4:45. Cameras on means keep your cameras on. And join the class. Do everything properly. Don't interrupt the class in between like this. It's not nice. I'm going to check homework things last now.
Understand.
Yeah. See, they're all real number lines, Ryan. So you have to mark with that black line. You can't separately number them. Okay, if it was natural or integers or whole numbers, then you have to mark each number separately. So how do you mark -2 to 5? It's a real number line. Show me all of yours. Here's yours. -2 to 5. This one, fifth one. Do that. Yeah. So if this is -2 over here, and if this is 5 over here, -2 will have a black dot because -2 is included. 5 will have a white dot, and in between that whole thing, you make it dark. This is how you do -2 to 5. Remember, these are real. See the heading, title? I mean, the question. Represent the following inequalities on the real number line. Okay. Same way, -5 to -1 also. Write it the other way first. So then other way, what will it be? Is -1, tell me. -1 less. Oh, sorry. It is already in the right order. I thought it was reversed. Okay, it's less than already. See, the sixth question, you'll have to reverse it. So the sixth question, how you'll write it? It's a greater than sign, no? So change it to less than. How do you change it to less than? Yeah, -3 less than x less than equal to 8. So write it like this first. Always your final answer should be in this form with the less than sign. If it is greater than, change it to less than. And then you do whatever you want with it. Either draw the solution set or the number line. Okay. Okay. Is everyone clear on this? You go to the second question here. For each graph given alongside, write an inequation taking x as the variable. So you're just doing the reverse. They've given the graph, you have to write the inequation. So tell me what's the first one. Okay, x is less than equal to -1. Right, from -1 is going to the left. So less than equal to because there's a black dot. Next one. Come on, tell me. Less than 2 means this side, man, left side. Greater. No, greater than 2 only is 2, 3, 4, 5. Right. So it will be x is greater than equal to 2. Next one, what is it? Now this has starting and ending.
Yes. Less than 2.
Here x will be in the center. Okay. And here you'll have like this. So where do you start? -4 less than or less than equal to. It's a black dot. So it's included, no? So less than equal to x less than 3. Here? You got it? Tell me the last one, Leah. -5. -1. Why less than equal to? It's a white dot. That means this -1 is not included. So will it be less than equal to? Just less than. Then x less than equal to because it's black dot. So 5 is included. Less than equal to 5. Everyone clear on this? Okay. Write in the question and the answer. Okay. Next, we're studying something new now. What is that new thing? When there are two less thans in one equation, in one inequation. In your book, it's question number 4. Here it is 3. Look at this. For the following inequations, graph the solution set on the real number line. And see here it is -4 less than equal to 3x minus 1 less than 8. How many of you know how to solve this? It's not started school yet? No. Okay. All right. So listen carefully. -4 less than equal to 3x minus 1 less than 8. Okay. So here they have 1, 2, 3. There are 3 parts here. Okay. In all the questions that we did now, there were how many parts? There were just 2 parts, left side and then right side. But now here you have 3 parts. Okay. So what you'll do is you will first solve the first and second part. Then you will solve the second and the third part. Then you'll join them both. Okay. All right. So first we'll do the first and second part. That is -4 less than equal to 3x minus 1. So like how you would normally solve it. Okay. So let's take the -1 to the left. That's -4 plus 1 less than equal to 3x. So -3 less than equal to 3x. That is -1 less than equal to x. Yes? Then solve the second and the third part. That is from 3x. So 3x minus 1 less than 8. Okay. So 3x is less than 8 plus 1. 3x is less than 9. X is less than 3. Yes. Now join these two. These two x's, you take it as common x in the middle. Okay. And on the left side of x, we have this minus 1 less than equal to. And on the right side of x, we have less than. We just joined those two together. Yeah. So minus 1 less than equal to x less than 3. And then you know how to solve this, put this on a number line, right? Right, minus 2, minus 1, 0, 1, 2, 3, go till 4. And then minus 1 is included, 3 is not included, and then a line in between. Clear? Write this down. Getting? So if you have to make both have the same less than on both one. If one is greater, one is less than, make both have the same inequality. Like here, see, this was less than, this was also less than. So it's okay. What if one was greater and one was less than? Then you make interchange, make both less than, that's all. Make both less than if it's not. Now here, what are you getting? X is less than 2. And the other one? Greater than equal to minus 2. So make both less than. So here you interchange these two. So that will become minus 2 is less than x. Then you write this first, and then you write the second. See over here, when you're solving this, 3 minus x is less than equal to 5. Don't take the minus x to the right here. Remember what we learned yesterday, that if you take the minus x to the right, it will become plus x. But what will happen here? The less than will become greater than. So for now, you don't do that step. What you'll do is, you will leave the minus x here. You will take the 3 on the right side. So that way you'll get minus x less than equal to 5 minus 3. So minus x is less than equal to 2. Now we'll take care of the minus x. So we'll take the minus on that side. So it will become x is greater than equal to minus 2. Okay, next question 7 in my book. See the question in your book. Must be 8. Yes. All right, solve this question. Find the range of values of x, means find all the values of x which satisfies this. So here, is it 2 parts or 3 parts? It's 3 parts, right? You can see less than equal to, again less than. So again, same like this, first and second first, then the second and the third part, and then join them back together. What, Leah, you're not understanding or what? Are you getting it or not? See, same like this. Here how it was, we split it into 2 parts. If there were 3 parts, first we did first and second part. And here we did the second and the third part. If you don't understand, please ask me.
I'm not getting of number lines.
What?
About the number lines, when we make the dark line,
Yeah, when it is real number, you have to put that dark line. If it is natural or whole or integers, then you have to separately mark each dot. Yeah. This has to be on the real number line, no?
sir, I got yesterday x greater than 4. So how to graph this on number line?
Is it real or is it integers?
Integers.
Integer means then greater than 4 means you will not include 4. Directly 5 you'll mark like this, like a dot. 6 you'll mark like a dot. 7 you'll mark like a dot. Okay? And just put an arrow like this.
In
Yes.
line we have
Not line, just put, see, listen, all of you. What if you have x is greater than 4 and x is integer? How will you draw this on the number line? Integer means you have to mark each dot separately. Correct? Integers. If it's real numbers, you will draw the black line. If it's integers or whole number or natural numbers, then you will mark each dot separately. Correct? So if x is greater than 4, how do you mark this? So greater than 4 means 5 onwards. So you mark each number 5, 6, 7, 8, 9, and it goes till infinity. So you can just put 3 dots like this here. So that means it's going till infinity. Correct? This is how you mark integers. If the same thing was real numbers, then how would you mark it? You will not put all these dots. How will you mark the same thing if it's real? Tell me. If it was real, if x is greater than 4 and x belongs to real number, how will you mark it? So greater than 4 means you will draw white circle and then you will draw black line. This is if it's real. Real means you're including everything in between, all the decimal points. That's why we are drawing a black line. Integers means you're only including the whole numbers, the integers, no decimals. That's why we're marking each number separately. Okay. Okay, solve 34, then 36. Anyone got this 34th one? What did we get? That's one part. Other part? Both are less than only. Okay, let's see. Anyone else got anything?
So I got a x is less than 5.
Just 5.
Less than 5.
Okay, join them both then. I'm getting -5 greater than x. Okay, just see how it is done. If you didn't do it right, see what's your mistake. That's not lowest, but okay, you can make 12 if you want. Do it, still you'll get the same answer. Show me what you did. Wait, how? -60? -34, -6. So,
Sir, I did in the beginning only. Instead of shifting 1/2, I shifted my -2x upon 3 that side and -17/6 on that side.
you change the less than to greater than.
No, sir. That's
Yeah,
the
just in the beginning, before this, I told me if there's only one x term, don't shift the x term. See, what did you get, Ahmed? What is your final answer for this left side first part?
x is less than 5.
See, that's wrong. It's supposed to be x is greater than -5. This is what you're supposed to get. Where this? Oh, there's a minus here. Okay, wait, I think I made a mistake here. So here it is supposed to be -5, okay? Minus. And then when you remove this, this will become +5, okay? And then when you interchange, x is greater than 5. Yeah. What did you get, Ahmed?
X is less than 5.
You got less than 5. Yeah, it's supposed to be x is greater than 5. So what you did, when you remove that x to the other side, and if it is negative, you have to change the less than to greater than. You have not done that. That is why you got that wrong. So that's why I said what you
Yes.
should. There's only one x term. What do you do? Don't move that x term. Is that clear?
Yes, sir.
You continue as well. You didn't get it? Show me. Don't cut and do this. Do whatever you're doing, just correct your mistake. Show me what you did. Show me, tell me why is this wrong? What should I do here? How do I correct it? And correct what you have done. Don't just copy down what I've done.
Minus 3 is 5 greater than x.
5 is greater than x.
That's the 5. How we x greater than
Correct. Okay, listen. There's another mistake. Okay, so look here, all of you. So if you have this minus 5 less than minus x, what should we do next?
Interchange both.
No, take the minus sign to the other side. So if you take this minus over here, this minus 5 will become plus 5. This less than will become greater than, and this will become x. Correct? Okay. Now we don't like greater than signs. We need to make it less than. So we'll interchange both the sides. So when we interchange both the sides, you have x on this side less than 5.
I didn't understand last paper.
You're just
So,
inter-
5 is greater than x. We cannot write like that.
you can write, but just as a standard, you make everything in terms of less than. It'll be easier to draw the number line, easier to understand it. Just write it as less than. So you're just interchanging both the sides, you'll get less than.
Yes, sir.
Minus 10.
What?
In a whole year.
Keep the minus x down here. Take the 3 on top here and the 2 down. Cross. You need to find x, no? So keep x over here. Take the 3 on top here and this 2 down here. So 3 will go up with the 10. Multiply with the 10. Minus down here is 3 into 2 less than minus.
So I thought for second part, x is less than equal to 1/2.
X is less than 1 upon 2. Anyone else? Second part, what do you got? Huh?
Less than equal to.
Okay. What? 5 is greater than x. Then you interchange and write x is less than 5. Okay, I'm doing the next part. So I'm not moving the x term. Leave, because there's only one x term, leave the x term right there. Move the 1 upon 2 to the right. So it'll become minus 1 upon 2. Then you multiply 2 into this 2, shortcut. That's minus 2x upon 3 less than equal to 2 2s are 4 minus 1 whole divided by 2. So that's minus 2x upon 3 less than equal to 3 upon 2. Now keep the x over here, move the numbers on the other side. Leave the minus also here. So minus x, we leave it here. And this 2, where will it go? Down. That 2 will come here. And this 3 will go on top. So that's minus x is less than equal to 9 upon 4. Is that what you got? And then minus you have to remove. So if you take the minus on the other side, you'll have x is greater than equal to minus 9 upon 4. And then you convert 9 upon 4 into a mixed fraction. So x is, or before that you interchange both, because you need the less than sign. So now when you interchange, what will happen? Minus 9 upon 4 less than equal to x. Yep. And then you convert minus 9 upon 4 into a mixed fraction. So 4 into how much is 9? 4 twos are 8. Carry 1 upon 4 and then minus. Now put them together. So first we'll write this. That's minus 2 1 upon 4 less than equal to x. And then this one, because that's coming on the right side of x. That is less than 5. This is your final answer. Now you have to represent this on a whole number line. Whole means you'll start from 0, even though it's including some negative numbers. See, if it was integers, what would you do? Tell me. If it was integers, then you start from minus 3, minus 2, minus 1. Okay, and where is this minus 2, 1 upon 4? Where would it come? Somewhere over here. Minus 2, 1 upon 4 means after minus 2, 1 upon 4. You're dividing that into 4 parts and the first part. Okay, so we don't need to go very accurately and draw 4 divisions or anything. We're just approximately writing this point here as the minus 2, 1 upon 4. Okay. Yeah, and if it was real numbers, then you will put a black dot here and then like that. Understand? But if it is integers, then you don't need to worry about that. The first integer over here is where? Minus 2. So you don't need to draw these dotted lines or anything. If it's integers, you will directly show these and so on. But here this is whole numbers. So whole numbers means you won't even show the negative. Where you'll start from is from the 0. The first number will be 0, then 1, then 2, 3, 4, 5. Do one more. 6. This is your final answer. 5 is 5 included? No. So till 4.
Lights on
Huh?
5.
What?
Light circle or not?
No
full
circle
bold
at
circle.
No circle at all on 5. That is only if it's real numbers. If it's integers or whole numbers, you are showing only those numbers which are included. So 5 is not included at all. 4 is included. So just draw a dot on 4.
Right, like this. First we got x less than 5, 4. You wrote in the answer minus 1 upon 3.
I wrote that on this side, on the right side.
It is for it can anyhow you write this side or this side. It will give marks. No?
You write from small to big. From small to big. So small is this minus 2, 1 upon 4 is small. So you write that first.
Yes, sir.
And then the big on the right side. So you have to write from small to big. Okay, after this do 36.
So when we shift that in 36th question,
Huh.
in first solving, if we shift 7x to that side and that minus plus 21 to that side, so sign will change. It's greater than, so it will change to less than.
No, no, no. When there are 2, you don't change anything. Only if there's one x term and you move it, you'll have to change.
Yes. So for first, I got x is greater than is equal to 1 to upon 2.
Okay. X is equal to minus 3 upon 2. X is greater than equal to minus 3 upon 2. This is what you got? Everyone?
Yes.
Yes, sir.
And for the second one, what did you get? X is less than 2. Okay, so both you have to make less than. So here you will interchange this. So you'll write that as minus 3 upon 2 or minus 1 upon 2 less than equal to x. And then join this to the right side. It will be less than 2. This is what you all got. Then on the real number line, so start with minus 2, minus 1, 0, 1, 2, and 3. So here real number, so it's a black dot and the white dot thing. So minus 1, 1 by 2 comes right in the middle here. Okay, so you can just put a line downwards like this and write that this is minus 1, 1 upon 2. And here you will draw the black dot. And then less than 2, so 2 is not included, so white dot. Then you draw it, join like this.
Solve that second part solving of that 20.
X is less than 2.
Yes, that one. 15 minus 7x greater than x.
So 3 will get multiplied with the 15 minus 7x. So that will become 45 minus 21x greater than x plus 1.
Yes, sir.
Take either the x term to the left or the minus 21x to the right. So if I take the minus 21x to the right, let's see. So that's 45 minus 1. Did you all do this way or did you take the x to the left? All of you do this way? Okay, then I'll do the other way. Let's see if we get the same answer, okay? So I'll take the minus 21x to the right. No, wait, what? No, I have to take the x to the left, no? Okay. So that's minus 21x minus x greater than 1 minus 45, correct? So that's minus 22x greater than minus 44. So keep the minus x over here greater than minus 44 upon 22. So then that will be minus x greater than minus 2. And then you take the minus on the other side. So x will be less than 2. See, both ways you can do. When there are two x terms, you can shift any of the x to whichever side. Only if there's one x, don't shift that x. Keep this in mind. These are all the differences between linear equations and linear inequations. Everyone clear on this?
1 upon 2 on the number line where it will come on
Between
the scale.
1 and 2. 1 upon 2 is between 1 and 2. So between 1 and 2, you will draw the dot and then that's where it is. Okay, your homework is to complete this chapter. We're done with this chapter.